Optical Diagnostics and Imaging Laboratory, we work with optics and lasers for very challenging problems in engineering measurements. For example, measuring things in reacting and non-reacting flows, some physical properties such as the temperature, pressure, velocity of flow fields involved in engineering applications, as well as chemical composition.
I'm Gavin Lukasik. I'm a PhD student here. What we have is a little Schlieren system. So we have these two really large lenses, and essentially we collimate some light through here, and we're going to be using this system to examine hypervelocity impact sound waves. This is our LIVS laser card. So taking a pulse laser, basically we can take some material, turn it into plasma, and by reading the emission from that plasma, we can tell about it.
Hi, my name is Christian, and I am a PhD student here at Texas A&M. So one of the things that I'm working on is advanced laser measurement methods for process safety equipment. And one of the things that we have found out in our research is that it's often difficult to bring our lasers to the equipment that we're using in other labs. So one of the things that we're working on is actually replicating some of the function of the process safety equipment here in our own lab, so we can use our larger lasers in the systems.
My name is Yejun, and I'm a postdoc researcher in this lab. So here I'm going to show you this is a femtosecond lasers. So it's different from the nanosecond. So the femtosecond laser, so with the pulse duration is very short. This only around 80 femtoseconds, but the bandwidth is so much broader than the nanosecond lasers. This is another type of the Leyak laser, similar to the laser card. So this is still also the 10 Hz laser. And we also use this laser to pump this dye laser. So then we can use this dye laser to tune the wavelength to the UV range. And this can use it for the combustion diagnostics.
This is Will Swain, a Master of Science student here in the lab. So what I primarily work on is this guy right here. So you may have seen before like a burner, like a flat flame or atmospheric pressure burner, and that's really what has been conventional use in combustion research up until late. And so now what we're doing is that if you have like an internal combustion engine, or an airplane engine or something in your car, that's going to operate at higher pressures, right? And so what we've done here is that we've created a high pressure burner for realistic replication of airplane engines, gas turbines, and car engines.
Howdy, I am Pradeep Rajali. I am one of the PhD students under Dr. Kulatilaka's lab, and today I am going to talk about this nanosecond laser. Here we can see two laser systems employed together to conduct a laser-induced fluorescence imaging of intermediate species in laboratory frames.
So that's what we do in the Optical Diagnostics and Imaging Laboratory.